this episode, we focus on the stage of the AI life cycle that teams are most likely to forget until it becomes urgent: retirement. Artificial intelligence, AI, systems often begin with excitement and momentum, but every system eventually reaches a point where it must be shut down, replaced, or fundamentally changed. Retirement can happen because the model is obsolete, the business process changes, the vendor relationship ends, the risk becomes unacceptable, or regulation changes what is allowed. Beginners sometimes imagine retirement as simply turning something off, yet in risk management, retirement is a careful process of closing doors, cleaning up sensitive data, and ensuring the organization can still explain what happened in the past. The title gives us three anchors for what safe retirement really means: data deletion, archiving, and lifecycle closure. Data deletion is about removing what should not remain. Archiving is about preserving what must remain for accountability and continuity, and lifecycle closure is about ending the system's story in a way that prevents hidden dependencies and lingering exposure. By the end, you should be able to describe why retirement is a safety control, not an administrative chore. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A useful starting point is to recognize that an AI system is rarely a single object you can switch off, because most real systems are bundles of components. There may be a model version, a prompt or configuration layer, one or more data connectors, logs and transcripts, evaluation records, monitoring dashboards, vendor accounts, and internal documentation. There may also be downstream systems that depend on the AI outputs, such as workflows that route tickets, generate drafts, or feed analytics. Retirement becomes risky when teams only remove the visible user interface while leaving the invisible components alive, because those invisible components can still store sensitive data or still provide access pathways. Beginners often assume that if users cannot click a button anymore, the system is gone, but risk management treats the system as the entire ecosystem that supported the feature. Safe retirement therefore begins with a full inventory of what exists and what depends on it, because you cannot close what you cannot name. This inventory is not busywork. It is the map that tells you where data lives, where permissions exist, and where latent risk remains. When retirement is planned, the system ends cleanly, and when retirement is improvised, the system leaves behind ghosts. Data deletion is one of the most sensitive parts of retirement because it sounds straightforward but becomes complicated in practice. Deletion is not only about removing files. It is about removing sensitive content from all the places it was stored, copied, logged, and backed up. In AI systems, sensitive data can exist in conversation transcripts, in stored prompts, in retrieved document caches, in evaluation datasets, and in monitoring logs. It can also exist in training data snapshots or fine-tuning datasets if the system used internal or customer content for improvement. Beginners sometimes believe deletion is a single operation that instantly removes data everywhere, but in reality, data can be replicated across systems for resilience and performance. Safe deletion requires you to know what counts as deleted in your environment and in your vendor environment, including what happens to backups, replicas, and analytics stores. Another critical concept is that you should delete based on purpose limits, meaning data that no longer serves a legitimate purpose should not remain. Retirement is often the moment when the legitimate purpose ends, so retaining data becomes harder to justify. When deletion is executed carefully, it reduces long-term exposure and reduces the chance of future leakage. One of the hardest deletion questions in AI retirement is whether model behavior itself contains sensitive information that needs special attention. If the system was trained or fine-tuned on sensitive content, then deleting the source dataset does not automatically remove the influence from the model, because the learned patterns may persist. Beginners may find this surprising, but it matters because it affects what it means to retire a model safely. In many cases, safe retirement means ensuring the model can no longer be accessed or used, even internally, because the safest way to prevent leakage is to prevent use. It can also mean ensuring that derived artifacts, such as fine-tuned variants or cached embeddings, are removed or access restricted so they cannot be reused accidentally. Another issue is that teams sometimes reuse models for new purposes because it feels efficient, but reuse can violate purpose limits if the original training data was collected for a specific use. Retirement is where you enforce the boundary that this model and its data influence are no longer authorized for continued use. When you treat model artifacts as part of the deletion scope, you reduce the chance of a retired system being quietly resurrected in an unsafe way. Archiving is the second anchor, and it can seem like it conflicts with deletion until you understand why both are necessary. Archiving is about preserving records that are needed for accountability, compliance, and organizational learning, even after the system is no longer active. For example, the organization may need to retain certain audit artifacts, decision approvals, incident records, and performance validation evidence to demonstrate that the system was governed responsibly while it operated. Archiving can also preserve documentation about known limitations, risk assessments, and governance decisions, which helps future teams avoid repeating old mistakes. Beginners sometimes think archiving means keeping everything, but responsible archiving is selective and controlled. You should archive the evidence that proves control, not the raw sensitive content that creates unnecessary risk. This is where minimization applies again. Archive what is necessary, redact or summarize what is risky, and limit access to archived materials. A well-designed archive becomes a secure memory of the program, while a poorly designed archive becomes a new sensitive data pile. Safe retirement requires the organization to balance these needs with intention. A critical part of archiving is deciding who can access the archive and under what conditions, because archived records can contain sensitive context even when raw data is removed. Access to archives should be governed by roles like compliance, legal, security, or auditors, and access should be logged so accountability remains intact. Beginners sometimes assume archives are only for auditors, but archives are also for incident investigation, vendor disputes, and internal learning when similar systems are built later. That said, broader access increases risk, so archives should not be treated like a shared drive where everyone can browse. Another important archiving concept is integrity, meaning archived records should be protected from tampering so they remain credible evidence. If archive validation results can be altered later, the archive loses trust value and becomes a liability. Archiving also includes preserving version context, because records must be tied to the specific model versions and configurations that existed at the time. Without version context, archived evidence becomes confusing and less useful. When archives are secure, controlled, and well-labeled, they support lifecycle closure by ensuring the organization can tell an accurate story about what happened without keeping unnecessary sensitive content. Lifecycle closure is the third anchor, and it means ending the system in a way that prevents lingering operational and governance risk. Closure includes disabling access, removing integrations, and ensuring that dependent workflows have been updated so they do not continue relying on a system that no longer exists. It also includes updating documentation and user guidance so people know the system is retired and understand what replaced it. Beginners sometimes assume people will stop using a system when it is officially retired, but in practice, people develop habits and shortcuts, and those habits can persist through unofficial workarounds. If a retired system still has an accessible API endpoint, or if an old plugin connection remains enabled, someone might continue using it without realizing it is unsupported, creating hidden risk. Closure, therefore, includes technical decommissioning and behavioral decommissioning, meaning you remove the capability and you remove the expectation. Another closure task is revoking credentials and service accounts associated with the system, because unused credentials are a common security risk. Closure is also about ensuring monitoring and alerting for the retired system are adjusted so they do not generate noise or hide signals for active systems. When lifecycle closure is complete, the organization can confidently say this system is gone and it will not surprise us later. One of the most common retirement failures is leaving behind data connectors and access pathways, because these are often invisible once the user-facing feature is gone. If the AI system had retrieval access to internal repositories, those connectors might still exist, and might still be usable by another service or by a compromised account. If the system had plugins that could call other tools, those plugin permissions might remain granted even after the model is retired. If the system used a vendor service, the vendor account might still exist with stored data, logs, or access keys, creating continued exposure. Beginners should recognize that retirement is a security event as much as it is an IT event, because it involves removing attack surfaces and cleaning up privileges. A safe retirement plan includes a clear list of access rights to revoke, connectors to disable, and integrations to remove. It also includes confirmation, meaning you do not assume removal happened, you verify it through evidence. Verification matters because misconfigurations are common, and an incomplete retirement can create a false sense of safety. When connectors and permissions are cleaned up, you reduce the chance of future leakage and misuse tied to a system that should no longer exist. Retirement also intersects with incident response and post-incident learning, because some systems are retired specifically because of repeated issues or unacceptable risk. In those cases, retirement should be treated as part of containment and recovery, with careful communication about why the system is being retired and what users should do next. A beginner misunderstanding is that retiring a system ends the obligation to understand what happened, but the opposite is often true. If a system caused harm, the organization may need to preserve certain evidence, notify stakeholders, and demonstrate corrective action, which can include retirement as a corrective action. Retirement can also be the moment to update policies, training, and governance gates so that future systems do not repeat the same mistakes. This is where archives become valuable, because they preserve the story of what went wrong and what was learned. Another key point is that retirement can reduce risk, but it can also create operational gaps, and those gaps can lead to unsafe workarounds if not managed. A responsible retirement plan, therefore, includes transition planning, such as replacement tools, updated workflows, and user support. When retirement is managed as a controlled transition, it reduces harm rather than shifting harm elsewhere. Another dimension of retirement is vendor relationships, because many AI systems involve third-party services that store data and evolve independently. Safe retirement includes making sure the vendor relationship is closed properly, which can include confirming data deletion commitments, terminating access keys, and obtaining evidence of decommissioning actions. Beginners sometimes assume that stopping payment stops risk, but vendor systems may still retain data and logs according to their processes unless specific deletion actions are taken. Contracts may include terms about data retention and deletion, but the organization must still execute the steps and verify outcomes. Vendor closure also includes understanding what happens to derivative artifacts, such as fine-tuned versions or cached embeddings, and ensuring they are not used by others. Another important point is that vendors may have subprocessors, meaning other parties that handle data, and closure may need to address those dependencies as well. This is why hidden dependencies matter even at retirement time, because you want to ensure the entire chain is closed, not just the most visible link. When vendor closure is disciplined, retirement becomes real rather than symbolic. Beginners also benefit from understanding that retirement is connected to governance discipline because governance should define what triggers retirement and who has authority to decide it. If the organization has no clear criteria for when to retire or replace a system, it may keep unsafe systems running because nobody wants to own the decision to stop. Retirement criteria might include persistent safety failures, inability to meet privacy obligations, inability to maintain performance under drift, unacceptable vendor instability, or the arrival of a safer alternative. Authority matters because retirement decisions can be politically difficult, and without clear decision rights, organizations delay until harm forces action. A mature program treats retirement as a normal life cycle stage with pre-planned processes, budgets, and responsibilities, rather than as a failure. Another important governance element is documenting the retirement decision and the actions taken, because later audits and investigations may ask why the system ended and what steps were performed to protect data. When retirement decisions are documented, the organization can show it acted responsibly rather than reactively. That documentation also supports future planning by showing what factors led to retirement and what warning signs were present. It is also important to address the psychological side of retirement, because people often become attached to tools that help them, even if the tool was risky. If users relied on the AI system for productivity, they may resist retirement and try to keep using it through unofficial channels. This is where communication and training matter, because you need to explain why the system is being retired and what the safe alternative is. If you simply remove access without guidance, you create frustration that can drive shadow usage of uncontrolled tools, which can increase risk rather than reduce it. Retirement, therefore, includes change management for humans, not just for systems, and that change management should respect the fact that people have real workflows and deadlines. Providing replacement processes, setting expectations, and supporting users through the transition reduces the chance of unsafe workarounds. Beginners sometimes underestimate this human factor, but it is one of the most common reasons security controls fail. People bypass what blocks their work. When retirement is handled as a supportive transition, compliance becomes easier and safer behavior becomes more natural. As we close, retiring AI systems safely is about closing the life cycle without leaving behind data, access, and hidden risk. Data deletion removes sensitive content that no longer has a legitimate purpose, and safe deletion requires understanding where data lives across transcripts, logs, caches, training artifacts, backups, and vendor systems. Archiving preserves the evidence and records needed for accountability and learning, but responsible archiving is selective, access-controlled, and integrity-protected so it does not become a new liability. Lifecycle closure removes access pathways, disables integrations, revokes credentials, updates workflows, and ensures users stop relying on a system that is no longer supported. Retirement also requires vendor closure, governance authority, and human change management, so the organization transitions safely rather than creating shadow usage. For brand new learners, the key takeaway is that retirement is not a cleanup step at the end. It is a safety control that prevents future leakage and misuse. When you can describe how deletion, archiving, and closure work together, you are thinking in the full life cycle way that Domain 3 expects.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.